Okay, if you're solving and you have x in the exponent, you're going to either have to take the log or the natural log. Now, since I have base e, I'm going to take the natural log of each side. So the first thing I want to do is I want to isolate the base. So I'm going to divide both sides by 4. So I'm going to have e to the x equals 10/4, which is 5/2. Now the inverse of an exponential function is the natural log. So I'm going to take the natural log of each side. Okay, you want to put it on the left-hand side. It's not 5/2 times ln, it's natural log of 5/2. So what happens is when you use the properties of exponent, x comes out front, and the natural log, by definition, is equal to log base e of x. So just for this one problem, I'm going to write out, instead of writing the natural log, I'm going to write log base e, and then I have of e. So we know that this expression has to be 1, because e to the first is equal to e. So this is just, these two cancel out, so this turns into x equals the natural log of 5/2. So I'm going to calculate that. So in my calculator, the natural log of 5 divided by 2, the natural log button is right underneath the log button, is 0.92. So this is about 0.92 is my answer. Okay, number 9. We already have the base of the exponent isolated. So we can take the natural log right away of each side. So it's a natural log of e of x plus 2 equals 50. Now, using the properties of logarithms, x plus 2 is going to go out front. And remember, the natural log of e is going to cancel out. Oops, I forgot to write. Gotta erase this over here. I forgot to write natural log e over here, or natural log 50. So this is going to be, because I took the natural log on each side to keep the equation balanced. So this is going to cancel out, and now I'll have x plus 2 equals the natural log of 50, so I'm going to subtract 2. So this is not, so this will be x equals, this does not equal the natural log of 48. It's actually the natural log of 50, close it, the parentheses, and then subtract 2. So this is approximately 1.91. It's the nearest hundredth. Okay, the next one, I'm going to have to divide both sides by 4 to get the base of the exponent by itself. Now, in one step, I'm going to put the 3x plus 1 out front, and then I'll have the natural log of e equals the natural log of 5/4. So remember, natural log of e cancels out. And now I have 3x plus 1 equals the natural log of 5/4. So I'm going to subtract this quantity by 1 and then divide by 3. So x is, I'm going to do the natural log of 5/4, subtract 1 from it, and then divide that whole quantity by 3. And I get negative 0.26, and I'm rounding. Okay. Then down here, so if we're solving exponential equations, we're going to take the natural log of each side. These we're solving natural log equations, so we're going to write it in terms of an exponential equation. So I'm going to add 7. I want to isolate this, so I'm going to add 7. So the natural log of 2x equals 11. Now we can write natural log as log base e of 2x equals 11, because the natural log is log base e. Now I could write this as an exponential equation, e to the 11th equals 2x. In that case, my answer is going to be e to the 11th divided by 2, so a very large number. So I do e to the 11th, divide that by 2, and I get approximately 29937.07 if I round the nearest hundredth. Okay, 27. I want to isolate the natural log. So I have to subtract 3 first. So that's going to turn into a 9. Then I want to divide both sides by a -4. So I have a single natural log now. Sometimes you have to use the properties of logarithms to write it as a single logarithm. So now I can write natural log as log base e. So it's log base e of 8x plus 1 equals -9/4. Now, I have it written as a single log or single natural log, so I'm going to write this as an exponential equation. So e to the -9/4 equals 8x plus 1. At this point, I want to solve for x, so I'm going to take e to the -9/4, subtract 1, and then divide that quantity by 8. So I'm going to put that in my calculator. So I do e to the -9/4, subtract 1, and divide that by 8. And I get approximately -0.11 if I round the nearest hundredth. Okay, 28. I'm going to write this one as a single natural log first. So I'm going to use the properties of logs, and I'm going to multiply x times 3x. So I'll get 3x squared equals 14. So once I have it as a single natural log, I can write it as log base e of 3x squared equals 14. So I can rewrite this as an exponential equation. So it's e to the 14th equals 3x squared. So to solve for x, I'm going to divide both sides by 3. So I get x squared equals e to the 14th over 3. And then I want to take the square root. So technically this could be plus or minus. But if I look at my original problem, I can't put a negative number in for x because that will make that expression, part of the expression, undefined because you can't take the natural log of a negative number. So I'm just going to do, my answer is going to be the positive. So I'm going to do the positive square root of e to the 14th power and then divide it by 3. And I get about 633.14. Okay, next part, solve these. So, using your properties of logs, this will go out front. So it's going to be x ln e equals 3. But remember, ln e is equal to 1. So this is going to be x equals 3. And then number 33. So this one's a good no calculator problem. So 33, I'm going to divide both sides by 3 to get ln e to the 2x equals 4. But I can just pull the 2x out front by properties of logs. Then these two would cancel out because natural log of e is just 1, so x must be 2. All right, and then at the bottom, so an application of this is compounding continuously. So compounding continuously is this formula, a equals p e to the rt. Or a is the amount of money that you have after so many years t of compounding continuously at a rate of r. So p is the initial amount. So the question is, an investment is compounding continuously, so that tells me I need to use per, at 6.7%. So this is going to be my r. But I need to change the r to a decimal because right now it says a percent. So I'm going to move the decimal point over twice. How long, so you're going to want to find the t, will it take for their investment to double? So if the investment doubles, the a is going to be twice the p. So it doesn't matter if you start out with $10 and you get 20. Or if you start out with $200 and you end up with doubling that, to get 400, no matter what, if you divide both sides by here, you're going to get 2 over here. So the equation that we're solving is 2 equals 0.067 to the t power. So I'll write that over here. I'm solving 2 equals e 0.067 to the t power. So I'm solving this e equation an exponential equation involving e. So I'm going to take the natural log of each side, and then I'm going to use the property of logs. So this will go out front, and then these will cancel out to be 1. So it's going to be 0.067t equals natural log of 2. So I divide both sides by 0.067. So I'm going to do the natural log of 2 divided by 0.067. And I get approximately 10.35. So in about 10.35 years, your investment that's compounding continuously at 6.7% is going to be double. So again, it doesn't really matter what you put for these two numbers. You can put $1 million and $2 million. You can put $100 and $200. It's still going to be 2 equals e to your percent interest times your time.